Invention Tuesday. I have 3 cool inventions for you today, all completely different industries, but all made in the same fashion or made in the same way, and I'm going to talk about that a little bit. Let me show you those 3 inventions first. So the first invention is from the construction industry, and it's concrete tilt-up buildings. And how concrete tilt-up buildings work, you've probably seen them go up. I mean, they build these gigantic concrete warehouses, it seems like overnight. How they do that is they pour the walls flat down on the ground, so they pour all that concrete on the ground as a slab, and then they lift it up. So the problem is it's really hard to lift that slab up, but they use a crane to do that, and the problem is how do you fasten to the wall without having, you know, a bunch of steel sticking out that you're going to have to cut off later. So these guys at Burke came up with a gigantic solution that really kind of changing the tilt-up industry in construction. It's this simple little plastic box. And how this works is you take your steel anchor, you feed it over here, it comes down on this side, and that steel anchor goes into the concrete. This whole thing goes into the concrete. Then when the concrete dries, you pop this thing out and you have access to the anchor, and then you could just put a hook on there and lift that whole concrete slab up and lift it into place. So really inexpensive little plastic piece solving a pretty complex problem in the construction industry. The second invention is really clever. I love it. I have one of these at my house as well, and it's by Next Trend, and it's a garlic twist. And the problem with garlic, you know, a lot of people really don't like getting their hands all over it and cleaning up that big mess, and this solves all those problems. So how this garlic twist works is you crack your cloves of garlic. You could just use that if you want. You put your garlic cloves right in here, and then you just put it together and you grind it as finely or as rough as you want it. When you're all done grinding your garlic, you take that and just shake it right into your pan, and really easy to clean up, and you don't have your hands all over chopped garlic. So this is a Next Trend garlic twist, really clever invention. And then the third invention, I guess from the educational sector, this is a math game to teach fractions. You roll dice, and it's like playing Shut the Box, but you're using fractional tiles to teach students fractions. The idea is kind of based on a table saw tape measure, so that you can get a lot of iterations again and again till you get your fractions dialed in. So there are 3 separate inventions, 3 different industries: the home and kitchen, construction, and education. What all 3 of these products have in common is that they were all injection molded. And they're actually injection molded right here in the U.S. It's really cool how you do that. Kind of where it starts is you have a CAD drafting guy working with the engineer and the inventor. They come up with a plan of the product, whatever it is, and then working with the head machinist and CNC operator, they work up that CAD plan, and then they draw the negative of that CAD plan. So then it's going to be a big metal block where they cut out the negative of all of this, and they use a CNC router to cut all that out. And they're using a CNC router just like we use in class here, the same programming language, the same Mastercam. And then they cut out that big block of steel. That goes into the injection molder. And then in that injection molder, really quickly, plastic is injected in there, cools quickly. The tool breaks open, the plastic part drops out, and then you have your invention or your part like that. The upside is it's done here in the U.S., so quality control is excellent. You know exactly what you're getting: high quality plastics, high quality manufacturing, high quality tolerances, and quality assurance. The one downside is it's kind of expensive up front to build that tool, but once that tool is built, then you're able to run plastic parts for really next to nothing. So that's injection molding. I do have some video of when this game right here was manufactured. I actually went, this is my invention, and I went into the factory when they were manufacturing it, and you could see how these tiles were made. So I'll clip that to the end of this video. But before I do that, I'll just show you kind of, this is the tiles. These are called sprues. This is the plastic part inside the metal tool. The plastic is injected down in here, and then it fills all these voids, right? And then there's your plastic tiles and the ruler. And then as soon as it's injected in there, it pops open, this drops out, and then somebody snips up all of these little tiles and the ruler. All of the waste plastic goes back and is recycled, and then these parts are then stamped. It's really easy to make yellow and white parts. You just run whatever, a couple thousand of these, and then when you're done, you change the plastic into yellow, and then you run all the yellow parts. So that's design, Invention Tuesday, how it goes from an invention idea to the CAD program to the CNC program, and then from that CNC program, it's made into a negative tool, into an injection molder, and that's how things are made. I do actually have one other example. These eyeglass retainers right here have built-in hearing plugs, and this is an invention I've been working on, and it has like a little plastic clip here on there. So this I actually 3D printed, but once I have it perfectly prototyped and I like the way it's going to work, then I'm going to injection mold that little plastic piece, and that'll go on the strings, and that's so these eyeglass retainers can get held together like that behind your head. Knowing that the CNC skills we're learning in here are the skills that actually these plastic parts can be made. First production run. Here are the tiles and ruler in the box. Smooth. Tiles and ruler still attached. The sprue coming down. Here's our tool right here. There's the ruler, the gate, then the tiles. Sprue down the center, feeding it. These are the two cavity plates. Then on the back side are the pistons that push the part out. About a 500-pound mold. So here's a Haas CNC router that they build the tooling on, the molds on. Probably have to come down 5 thousandths on every tile. This is a machine shop where all the tools are made. Quality control in there. All about
this is the nozzle, comes in from the machine and butts up against it and shoots the plastic in there. This side is clamped to the A side of the machine and this side is clamped to the B. That's your parting line right there. So the shape is contained within these two plates right here. So the plastic solidifies when we get the shape we want. And so we're circulating cold water through there. It's being pumped through in tremendous volume actually from a big chiller system we have to extract the heat out. If we just built toothbrushes, it'd be boring. We have all the machines making toothbrushes and putting the bristle tree, which this is what we call the sprue. That's what you saw on the back of the mold where it comes in, where the nozzle would come in. This is actually in the mold itself, the sprue. It drops down to what we call a runner. And a runner ultimately is balanced out. You can see the geometry of it similar so that all the parts fill out at the same time. And this is the gate, and that's what allows the plastic to flow into your cabinet. We couldn't use ejector pins here, so that's why you see these deep pieces here, because this is actually in the mold, and this is where we're pushing it at. You can see your mold is bolted, clamped to the A and B side of the machine. This is the A side of the machine. You can see the high polish on there so that we get the similar effect on. The operator has to do is inspect the parts under the light to make sure there's not any real major flaws in it. Looks at it, if there's a big flaw like this one, it's got a big mark in it, they probably would not use that tile. That's just a little bit too much. It's outside the zone of the cosmetic standard we're going to use for this. So the operator will trim off the part right off of the tree right here, right off of the gate with some gate cutters. Just a manual process. They'll be trimmed off. They'll do it way better than me. Be a lot for the operator because you have 8 parts. That's a lot for them to do. They got to snip this all off, put it in a box in 30 seconds because that's about how long it takes to cycle the machine. Tesla cars, they're pretty famous. Every Tesla car that's sold, they actually get one of these as part of the sale, and they send out a technician to install this in the garage. This is the light pipe we make to transmit the light from the circuit board up, so it has, you see them everywhere with the green light on, or the yellow or the red light. That's actually plastic that we mold, and it actually lays down on the circuit board here and transmits the light from the circuit board right up through the plastic. Most of this was pretty much machine. There's a little EDMing here, but not much. You can still see the machine marks here. is a
big
plate
portion
that
of this
we
screen
create,
was-
and the image is burned into it about 3 microns deep with a chemical etching film. And once it's burned into there, that cup is full of ink. And the pad goes, it opens up, and then the pad goes down, picks up the image, and then I'm running it manual here. The pad go back, and then it would go down and print it on there. So the image is right here, right now.